Okay, so I'm going to go over your 4.5 Common Assessment. It's cumulative. Remember, we talked about this before I left. I'm going to go through each problem. You have the answer key in class that you have access to, but with the video, you can fast forward or pause where you need to. Just go to what you need to look at, and then you can check your answers that way. Okay, so the first part is operations with imaginary numbers. So the big thing is, remember, for your Common Assessment, you get to use the TI-83 or your personal calculator that's a TI-83 or higher. And the big thing here is remembering that A, D, and E can all be solved using the second and then the I right here. Just make sure you put parentheses around your terms just like it appears in the problem. And in the division, you want to put parentheses around your numerator and your denominator. If you get a decimal for D, remember we do second, math, inner, just like you would to get a fraction for anything. And it will give you that fraction answer, okay? So let's look at A. So I'm going to type this in my calculator exactly the way I see it. So it's going to be parenthesis 2 plus second, decimal place, which is going to throw that I in there, times 3 minus second I, and hit enter, and you get 7 plus I. Now sometimes with B and C, the calculator will give you an answer you understand, so you can always try that first. But if it doesn't give you something that makes any sense to you, then you have to know how to work these by hand. So remember, we always start with a base of I squared because we know that I squared is equal to -1. So how many times will 2 go into 58? So we do 58 divided by 2 is an even 29. So then I squared is -1 to the 29th power. Remember, if it's odd, it stays negative, even it's positive, so that's a -1. So again, we start with a base of I squared. 111 divided by 2 is 55.5, so that means it goes into an even 55 times, which gives me 110. So I need 111. So product rule says I can multiply by another I. So I have 110 plus 1 is 111. So I have -1 to the 55th power times I. So -1 to the 55th is -1, and -1 times I is -I. Okay. So in your calculator, you would type it just like this. Math, enter, so parenthesis 2 plus second I divided by parenthesis 5 minus 2 second I. And then I'm going to go ahead and hit math, enter, and it gives me 8 over 29 plus 9 over 29 I. Okay, so for the very last problem, do 2 parenthesis 5 minus I minus parenthesis 3 plus I, and you get 7 minus 3I. So your calculator screen should look exactly like that, exactly the way it is, and that will give you your final answer. Okay? So VA, HA, and POD, which is the same thing as a whole. So remember, vertical asymptote is what makes the denominator 0. Horizontal is the little over big, big over little, and same over same. And POD, which is a whole, means it makes the numerator and denominator 0 at the same time. So they should cancel. Okay, so in order to figure this out, we have to factor. So I have x plus 2 over x minus 5, x plus 2. So VA, HA, and POD, or whole. Okay, so I immediately see that I do have a POD because these two things cancel. So I have a POD at x is equal to -2. Vertical asymptote is the factor that makes only the denominator 0, which is going to be x minus 5. So x is equal to +5. And horizontal asymptote, this is little over big, which is always y equals 0. So letter B, again, we need to factor. So the top is a difference of 2 squares. Then we have the bottom. There's nothing else that can happen here. Nothing factors out. So we can do our VA, HA, and POD. So if nothing reduces out, then there's no POD. Horizontal asymptote, this is big over little, which is always undefined. And vertical asymptote is the value that makes only the denominator 0, which in this case is -2. So in the bottom, we need a factor. So the first thing I notice is has a GCF. So remember, you have to factor the GCF out before you do anything else. So I have x squared minus 2x, minus x minus 6 all over 2 times x squared minus 4, which is going to give me, so this is going to factor into a -3 and a +2. And then the bottom is a difference of squares. So I can do my VA, HA, and POD. So POD, I immediately see that x plus 2 factors reduces out in the top and the bottom. So that means I have a whole at x is equal to -2. My horizontal asymptote, this is same over same. Remember, this has nothing to do with the coefficient. The fact that the coefficients are same is just a complete fluke. We're talking about the degree of the polynomial. So it's a second degree over a second degree. And the horizontal asymptote is the ratio of the coefficients, which is 2 over 2, which means my horizontal asymptote is y equals 1. And my vertical asymptote is the value of x that makes the denominator 0, which in this case would be a +2, because these go away as my POD and leaves me with x minus 2. Has nothing to do with this 2 out here. That is just a factor, a numerical factor. Has no value toward my vertical asymptote. Okay, so it says list the transformations for each of the following and give the equation if it's not given. So transformations, this is a square root. So the -2 tells me it went down 2, and the inside is opposite, so it went left 1. So it's a quadratic. Remember, the original quadratic is at the origin, and it's turned up, so it hasn't been flipped. This is went left 2 and down 3. That equation would be inside is opposite and then down 3. So this is a quadratic. Remember, the original quadratic looks like this. Square root. The original square root looks like this, so it's definitely been flipped over the x-axis. It has went right 2 and up 1. So to show a flip, we have to do a negative out front. Right 2, remember, inside is opposite, so that would be -2, and then up 1 on the outside is +1. So a quadratic that's been compressed vertically by 1/2, translated 5 units, translated left 5 units, down 2 units, and flipped over the x-axis. So flipped needs to come first, so negative. A vertical compression is on the outside 1/2. It's a quadratic, so I'm going to have my parentheses squared, quadratic. Left 5 units, remember inside is opposite, so +5, and then down 2 would be -2 on the outside. So describe end behavior for each of the following. So remember, we have odd and even, and this is the degree. Remember, this has nothing to do with symmetry, which we will talk about later. And then this is a positive leading coefficient and a negative leading coefficient. So if it's an odd degree with a positive leading coefficient, then the right-hand side will go up and the left-hand side will be opposite. If it is an odd degree with a negative leading coefficient, the right-hand side goes down and the left-hand side goes up. So odd degree polynomials will always have opposite ends. Even degree will always be the same. So they go up, up, down, down. And you can remember the even with a quadratic, which is something you're quite familiar with. And you'll have your calculator so you can do a cubic. It makes no difference. So a 4th degree polynomial with a positive leading coefficient means that the both ends will go up. So as x approaches positive infinity, y will approach positive infinity. And as x goes to the left, or negative infinity, y will still go up to positive infinity. A 13th degree polynomial with a negative leading coefficient. So this is an odd degree with a negative leading coefficient. So that tells me that my right-hand side will go down. So as x moves to the right, y will go down. As x moves to the left, y has to do the opposite, so it will go up. Letter D, you just read the graph. So as x goes to the right, which is this direction, what does y do? Well, the graph goes up. As x goes to the left, what does the graph do? Well, it goes down. As x goes to the right, which is this way, the graph goes up. As x goes to the left, which is this way, the graph also goes up. So it says determine whether each of the following is even or odd degree and the sign of leading coefficient. So first, I know if they go in opposite directions, it has to be an odd degree polynomial. Also, I can see that it has 3 zeros, 1, 2, 3. Remember, we look at the right-hand side to tell me what the leading coefficient is, so it's going down, which means negative. So both ends are going in the same direction, which means this has to be even. Again, I can tell that there's 1, 2, 3, 4 zeros. So it's a 4th degree polynomial. Both ends are going up, which means it has a positive leading coefficient. So this is absolute value equation. So it says to solve. So the first thing we have to do is isolate our absolute value. So I'm going to add 1 to both sides, and I get 2 times x plus 1 is equal to 8. Divide by 2. Absolute value of x plus 1 is equal to 4. So once we get our absolute value isolated, we write two equations. X plus 1 is equal to 4, and x plus 1 is equal to negative 4. And then we solve, so x is equal to 3, and x is equal to negative 5. Same thing with letter B. We need to get our absolute value isolated first. So how do we get rid of a divide by 4? Well, we multiply. So I have the absolute value of x minus 2 is equal to 20. So once it's isolated, I can write two equations. X minus 2 is equal to 20, and x minus 2 is equal to negative 20. So then I solve. So I have x is equal to 22. And x is equal to negative 18. So absolute value inequalities work very similar. So the first thing we have to do is get our absolute value isolated. So I'm going to add 1. So I have 2 times the absolute value of x plus 3 is less than or equal to 6. Divide by 2. So I have the absolute value of x plus 3 is less than or equal to 3. So I have exactly what I see, just like equations. On the other side, remember when I flip the sign, I flip the sign. So this 3 becomes a negative 3, and I'm going to flip my inequality. Remember, we learned these. Once you get the absolute value isolated, this is a less than statement. So it's an and statement. So it has to be between this number and that number, which means it should be from a number to a number. So we subtract 3. We have x is less than or equal to 0. Subtract 3. We have x is greater than or equal to negative 6. So it's between negative 6 and 0. It has to be greater than negative 6, and it has to be less than 0. Letter D, again, we have to isolate first. So I have the absolute value of 2x plus 1 is greater than 11. So again, we do the same thing. This is a great or statement. So it is this or it is that. That's the ones with the infinity in them. So I write exactly what I see. And then the opposite, we flip the sign and make that a negative 11. So I subtract 1. So I have 2x is greater than 10. So x is greater than 5. So I have 2x is less than negative 12. So x is less than negative 6. So notice these do not go in the same direction. Negative 6 goes to the left of negative 6, and this goes to the right of positive 5. So it would be negative infinity to negative 6, union 5 to positive infinity. So radicals are a huge part of Algebra 2 and College Algebra. So the first thing, if I'm going to simplify, I know if I have a negative under a square root, I need to take that I out. So I have I times the square root of 75. So then I need to find the perfect square in 75, which is going to be 25. So then I'm going to bring out square root of 25 is 5i, and square root of 3 has to stay under there. To get a radical out of the bottom, it's very similar to those imaginary numbers. You multiply by the conjugate. So I have 1 minus the square root of 2 and 1 minus the square root of 2. So I'm going to distribute in the top. 2 times 1 is 2. 2 times negative square root of 2 is negative 2 square root of 2. So then we distribute in the bottom. Remember, these two terms should always cancel. If they don't, you definitely did something wrong. And then I'm left with 1 over, and the square root of 4 is 2. So I have 2 minus 2 square root of 2 over 1 minus 2, which is negative 1. 2 divided by negative 1 is negative 2. Negative 2 divided by negative 1 is positive 2, which leaves me with this. So letter C. So in order to add and subtract, remember we have to have like terms. So like terms mean it has to have the same index and the same radicand. So I need to do some simplification. So I have 2 times the 4th root. I need to find the perfect fourth in 405, which is going to be 81, 3 to the 4th, minus 3 4th root of 16 times 5, which is 2 to the 4th, minus 3, the cube root of 192, so I need to find the perfect cube in 192. Which is going to be 64. So then I'm going to take that out. So I have 2 times the 4th root of 81 is 3, 4th root of 5, still trapped under the radical. 3 times 4th root of 16 is 2. Be very careful here because you're going to want to write 4, but it's 2. 4th root of 5, and the third root of 64 is 4 cube roots of 3. So I have 6 4th root of 5 minus 6 4th root of 5 minus 4 cube root of 3. So these two cancel and leave me with a negative 4th root, or 4 times the cube root of 3. Letter D, so the first thing that I would try to do is simplify. If it doesn't simplify, you can multiply by the cube root of 7 squared, but this definitely simplifies. 12 divided by 4 is 3, times the cube root of 875 divided by 7 is 125, which is beautiful and convenient because 125 is a perfect cube. The cube root of 125 is 5, and 3 times 5 is 15. So number 7, solve each of the following. So this is those rational inequalities. So I'm going to factor first. So then we find our critical values by setting our factors equal to 0. So we get x is equal to negative 4 and x is equal to 3. So we do our number line. So we have negative 4 and 3. Have an equal to sign, and it's a quadratic, so they're both equal to. So then I pick a number in each section. Don't have to pick the same number I do. Should work out either way. Now I like to plug in here just because the math is easier and I don't need a calculator. So negative 5 plus 4 is a negative. Negative 5 minus 3 is a negative, and two negatives make a positive, which is what I'm looking for. 0 plus 4 is a positive. 0 minus 3 is a negative. A positive and negative make a negative, which is not what I'm looking for because it says greater than 0. So 4 plus 4 is a positive. 4 minus 3 is a positive, and two positives make a positive, which is what I'm looking for. So my happy face touches an arrow, so that's negative infinity to negative 4 included. Union 3 included to positive infinity. Remember, infinities always get parentheses. So letter B is already factored for us. So we're just going to take those factors and set them equal to 0. So I get x is equal to negative 2 and x is equal to 7. So number line. So this is not equal to, so both of them get an open circle. So I'm going to pick a number in each section. Doesn't matter what you pick. Just make sure it's in the right section. I'm going to plug into the original. Negative 3 plus 2 is a negative. Negative 3 minus 7 is a negative. And two negatives make a positive, which is not what I'm looking for because it says it wants less than 0. 0 plus 2 is a positive. 0 minus 7 is a negative. A positive and negative make a negative, which is what I'm looking for. 8 plus 2 is a positive, 8 minus 7 is a positive, and two positives make a positive, which is not what I'm looking for. So my happy face is trapped between negative 2 and 7, both not included. Okay? Now remember, I know I'm moving through quickly. It's just because I don't want this video to be any longer than it needs to be, because you can pause this, you can go back, fast forward, rewind, whatever you need to do to get to what you need to see, okay? All right, so we have these equations to solve. So I need to get the power by itself, or what's raised to the power by itself. So I'm going to subtract 2 on both sides. So remember that 1/2 power, so the square root of x is equal to x to the 1/2. So to get rid of the square root, we square both sides. Don't get this confused, and 1/2 both sides, because it's not the same. So then I have x plus 2 is equal to 64. So x is equal to 62. Same thing here. Remember that the cube root of x is equal to x to the 1/3. So I need to isolate first. So I have 3 times x plus 1 to the 1/3 is equal to 9. Divide by 3. So x plus 1 to the 1/3 is equal to 3. So I need to cube both sides, not multiply by 3. To be clear, we are not multiplying by 3. So I have x plus 1 is equal to 27. If you're going to mess up, this is going to be the step that you do it in. Remember, it's a multiple choice test. You can bank on the answer being there for if you put a 9 instead of a 27. So I have x is equal to 26. So this is a rational equation. So remember, for an irrational equation, the first thing we have to do is factor. So I have p over p plus 2 over 8 times p plus 2, p minus 2. You have to factor because you have to multiply the entire problem by the least common denominator, which in this case is going to be p plus 2, p minus 2. And every term, a lot of you have a bad habit, I noticed on the test or quizzes really, of not multiplying that constant by that, but you have to do that. So then we're going to mark out, which leaves me with p times p minus 2. Nothing marks out in this one. So I have 2 times p plus 2, p minus 2 is equal to, and then the whole thing marks out and leaves me with 8. So work smarter, not harder. So distribute p squared minus 2p. This, we already know what it's going to be. It's p squared minus 4. We just unfactored it right there. Is equal to 8. So I have p squared minus 2p plus 2p squared minus 8 is equal to 8. So I'm going to combine like terms. So I have 3p squared minus 2p minus 8 is equal to 8. So I'm going to subtract 8 on both sides. So I have 3p squared minus 2p minus 16 is equal to 0. So I need to bottoms up. So I have p squared minus 2p minus 48 is equal to 0. So I have p minus 8, p plus 6. That's not my answer because I have to divide that 3 back out. So I have 3p minus 8 and p plus 2. So I have 3p minus 8 equals 0 and p plus 2 equals 0, which gives me p is equal to 8 over 3 and negative 2. This one has to be thrown out because it makes my denominator 0. A negative 2 plus 2, a negative 2 squared minus 4. Either way you check it, it only has to make one of the denominators 0, not all of them, just one, and it has to be thrown out. So that leaves me with p is equal to 8 over 3. So rational expressions, remember we factor and then simplify. So the top factors x minus 5, x plus 3. Bottom is a difference of squares, so x plus 5, x minus 5. Times the numerator has a GCF, so I'm going to take it out first. Remember, if you don't take the GCF out first, it will disappear when you do bottoms up, and then you're going to miss the problem because you're not going to have that factor of 2 out there. And the bottom has a GCF of 4x. So one more time. So then we can cross out. We have an x minus 5, x minus 5, plus 5, plus 5, plus 3, and a 2 and a 4. But don't forget your x. So that leaves me with an x plus 4 in the top over 2x. Be super cautious not to mark out the x's or the 4 and the 2. You cannot do that. That's a binomial. You can only mark out a cross multiplication. So this is division. So remember that when we divide, we multiply by the reciprocal. So I'm going to fix that before I even touch my factoring. So the reciprocal of x squared over 1 is 1 over x squared. So I have a GCF, 5x squared. It leaves me with x minus 6. It's going to leave me with x minus 6, x plus 2, times 1 over x squared. So my squareds go away, my minus 6 goes away, and leaves me with 5 over x plus 2. Letter C, so this is just a simplify, no addition, no subtraction, no multiplication, just simplify. So this means I just need a factor. So the top is a difference of perfect cubes, which means I factor a very specific way. So first we get the binomial by taking the cube root of each term. The cube root of 8x cubed is 2x. The cube root of negative 27 is negative 3. And then we SOPs this term, not the original. We SOPs this term. So square of the first term, so 4x squared, opposite sign, product of these two things, which is 6x, plus the square of the last term, which is 9. All over. So this one needs bottoms up, so I'm going to come to the side and do that. So I have x plus 4, x minus 3, divide my 2 back out, and I have x plus 2 and 2x minus 3. So we need to simplify conveniently. So then we're left with 4x squared plus 6x plus 9, x plus 2. Now, 9 times out of 10, that numerator does not factor. So there's no point in trying in this particular problem because no matter how it factors, I know that the last number cannot have a 2 in it because 2 times nothing is 9. But always check to see if it factors. But again, 9 out of 10 times it does not. So don't panic if it doesn't factor. It's okay that it doesn't factor because it usually doesn't. Okay? Alright, so this is just basic compound inequalities. So we need to solve for x. So if I do it here, I have to do it here and here. This is an AND statement. So I have negative 4 is less than negative 2x is less than or equal to 4. Divide everything by negative 2. Remember, when you divide or multiply by a negative, you have to flip the sign. So it gives me 2 is greater than x is greater than or equal to negative 2. Now you may want to flip this around so that you don't write it incorrectly. So you have negative 2, pointy side, x, pointy side, not equal to 2, which means that my solution is negative 2 included because it has equal to, positive 2 not included. Okay, so then an OR statement says we solve this one, and we have those infinities at the end. So minus 1, 2x is greater than 4, divide by 2, so x is greater than 2. Divide by 5, and x is less than 9 over 5. So these go in opposite directions, so we have negative infinity up to 9/5, not included, union to positive infinity. And you can sketch out your number line if you need to make sure that you're doing this right. So an AND statement should be bound between two numbers, which means my solution should be meeting in the middle. So minus 4, so you have negative 3x is less than 9. Divide by negative 3, so we have to flip our sign. So x is greater than negative 3. So subtract 2. So x over 4 is less than or equal to 1. Multiply by 4. X is less than or equal to 4. So again, these solution sets are going to meet in the middle. So we have negative 3 not included, up to 4 included. And again, you can sketch out your number line if you need to do so, okay? So remember to determine if something is even, odd, or neither. So we plug in a negative x if it's exactly the same. It's even. Exact opposite, it's odd, and if it's neither one of those things, then it's neither. So f of negative x is equal to negative x cubed minus 5 times negative x, which is equal to a negative cubed is a negative, and a negative times a negative is a positive. So every single sign has flipped, so this is odd. Okay? So f of negative x is negative x squared minus 4. Negative squared is a positive, so x squared minus 4. It's exactly the same, so it is even. F of negative x, 1 over negative x squared plus 4. So I have 1 over, a negative squared is still a positive. So it's exactly the same, so this is even. So f of negative x, so we have the negative of negative x cubed minus 2 times negative x minus 3. A negative cubed is a negative times a negative is a positive. A negative times a negative is a positive, and then the negative 3. So this is not exactly the same, it's not exactly the opposite, so it is definitely neither. And then we have f of negative x is equal to 5 minus negative x squared plus negative x to the 4th. And negative squared is a positive. A negative to the 4th, or an even power, is still a positive. And notice I said positive here, but I wrote a negative because a negative squared is a positive times that negative is still a negative. So it's exactly the same, so this is even. Now remember, this is referring to symmetry, not the degree. So when we were talking about in behavior earlier, that was referring to the degree of the polynomial. This is referring to its symmetry, how it is symmetric. Remember, an even function is symmetric to the y-axis, meaning if I fold along the y-axis, the graph will lay on top of itself. Odd has rotational symmetry. That's the one where I stuck my finger on the board and spun the piece of paper. The graph looks the same way upside down as right side up. Okay. Number 11, solving quadratics. Multiple ways you can do this. You can do square root property. You can do completing a square. You can do quadratic formula. You can use your calculator. It makes no difference to me. If you have imaginary or irrational solutions, you're likely not going to find those in the calculator. but going to the calculator is not necessarily a bad idea. So I'm going to isolate x squared and use the square root property. So I have 5x squared is equal to 540. Divide by 5. So x squared is equal to 108. So x is equal to plus or minus the square root of 108. So 108 is not a perfect square, but it contains a perfect square of 36. So I have x is equal to plus or minus 6 square root of 3. Make sure that your plus or minus is out front and it doesn't become 6 plus or minus the square root of 3. Okay? Notation is very important. So here, first go-to would be to try and factor, and you might think that it factors like a -4 and a -1, but a -4 and a -1 would make a +4 here, which it's not. So this does not factor. So I'm going to do quadratic formula. So a is 1, b is -5, and c is -4. So x is equal to the opposite of b plus or minus square root b squared minus 4ac all over 2a. So the opposite of b is a +5 plus or minus -5 squared minus 4ac all over 2 times a. So x is equal to 5 plus or minus, so my calculator, -5 squared minus 4 times 1 times -4 gives me a +41 over 2. And 41 is prime. So there's really not anything I can do after that. If 41 was not prime, you would definitely simplify the radical and go from there, okay? Letter C, I'm going to use the square root property just like I did in A. It's a little bit different, but not much. So I have 3 times x plus 2 squared is equal to -15. Divide by 3. So x plus 2 squared is equal to -5. So x plus 2 is equal to plus or minus the square root of -5. So I'm going to get my x isolated. And we know we cannot leave that negative under a square root. So that's going to be 2 plus or minus I square root of 5. So simplify each of the following and write in simplest radical form where appropriate. So remember, product rule says that when we multiply two like bases, we add their exponents. So I'm going to do 2 plus 2 divided by 3. Math enter, enter. And that gives me x is equal to 8 over 3. And if I want to write this in simplest radical form, remember the bottom is the root, the top is the power. So in order to simplify this, I need to find the maximum number that 3 will go into that's less than 8, which would be 6. So 6 plus 2 is still 8, still equivalent. The cube root of x to the 6th is x squared times the cube root of x squared, which is trapped. So in order to multiply these, I cannot multiply them as they sit because they are not like index. They don't have a like index. So I'm going to rewrite them as exponents. Now I have two like bases that I can add. So I have 1 divided by 2 plus 3 divided by 4, which is x to the 5 over 4. Be the 4th root of x to the 5th. Should be the 4th root of x to the 4th times x, which would be x times the 4th root of x. So we have a couple things happening here. We need to do product rule on top and then quotient rule. So luckily these have a common denominator. So this is going to be x to the 7 over 3 over x. Remember this is x to the 1, which is equivalent to 3 over 3. So 7 over 3 minus 3 over 3 is x to the 4 over 3. Which gives me the cube root of x to the 4th, very similar to letter B. So I have the cube root of x to the 3rd times x. The cube root of x to the 3rd is x times the cube root of x. So we're going to perform RRT and Descartes on each one of these. Remember that rational root theorem gives us our pool of numbers that we're going to pull from. And Descartes gives us our possible number of positive and negative roots. Okay, So we have RRT first. So I need to identify P and Q. So P is the last number, and I'm going to go ahead and write its factors. Q is the first. And we have plus or minus. P over Q gives me my list of possibles. So P over Q, so plus or minus 1 over 1, plus or minus 1 over 2, and then I'm done with 1. Plus or minus 3 over 1, and plus or minus 3 over 2. So that's my complete list. If I'm going to use synthetic division, if it has a real root, it has to come, a real rational root, it has to come from this list. Okay? For Descartes, the number of positives come from the number of sign changes. So I have 1, 2, and then we always subtract 2 until we get to 0 or 1. For number of negative, I plug in a negative and simplify and count the sign changes. So that'd be 2x to the 4th plus 3x cubed plus 2x squared minus 5x plus 3. So I have 1, 2 as well. So 2 or 0. So rational root for number 4, P is 2, so 1 and 2. Q is 4, so we have 1 and 4 and 2 and 2, but I'm not going to write 2 twice. So we have plus or minus P over Q. So plus or minus 1 over 1, 1 over 2, and 1 over 4. So I'm done with 1. 2 over 1, and 2 over 2 is the same thing as 1, and 2 over 4 is the same thing as 1/2. So that's my complete list. So my number of positives, I have 1, 2. My number of negatives would be negative 4x cubed minus 5x squared plus 3x plus 2, and I only have one sign change. So I only have one possible negative. Okay, so find all the zeros for each of the following using synthetic division. So rational root theorem, but this is a calculator test, and my job to help you with a calculator test with the ACT is to use the calculator to your advantage. So what I would do is I would put this in y equals and go to the table. You should be able to find at least one root that way. So 2x to the 3rd plus x squared minus 7x minus 6. And then you can do synthetic division to find the remaining. So the first one I see is negative 1. So I have then 2, 1, negative 7, negative 6. Now the reason it is very important to depend not just on your calculator, and you'll find this out in letter B, is if you have imaginary roots and those happen to be the ones that you are looking for, you're not going to find those in the calculator. Or if they're irrational, you're not going to find them in the calculator. So you have to know how to do the synthetic division in the event that that's what they're looking for. Okay, so we have 2. So 1 times negative 2 is negative, or negative 1 times 2 is negative 2. Plus 1 is negative 1, times negative 1 is 1, is negative 6, is positive 6 is 0, which is what we expected to happen. And this leaves me with 2x squared minus x minus 6 is equal to 0. This will be bottoms up. So x squared minus x minus 12. So x minus 4, x plus 3. And we need to divide by R2. So that gives me x minus 2 and 2x plus 3. So that means my list of zeros is my first one, negative 1, positive 2, and negative 3 over 2. So remember, if it asks you for the factors, just for reference, that would be x plus 1 from this one, and then the last two that we found, x minus 2 and 2x plus 3. Okay? So the same thing, I would go to my y equals for letter B, x to the 3rd plus x squared minus 4x plus 6. Go to my table, and I have 1 at negative 3. So I have 1, 1, negative 4, and 6. So negative 3 times 1 is negative 3, plus 1 is negative 2, times negative 3 is negative 6, positive 6, sorry, and 6 minus 4 is 2, negative 6, and 0, which is what we expected to happen. Then we have x squared minus 2x plus 2. Immediately, this does not factor. So I either have an irrational solution or an imaginary. So I'm going to do quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So 2 plus or minus the square root of 2 squared, or negative 2 squared minus 4 times 1 times 2, which is negative 4. So that's kind of nice. So I have x is equal to 2 plus or minus 2i over 2, which simplifies to 1 plus or minus I. So your zeros would be your negative 3, the first one that you found, and 1 plus or minus I. Okay, number 15, very last one. So operations with functions. So to add the functions, we just literally add plus 4x minus 3. So then we combine like terms. So I have x squared plus 6x minus 2. For f minus g, the big thing here is making sure that you distribute the negative all the way across. So I have x squared, 2x minus 4x is negative 2x. And 1 minus a negative 3 is plus 4. So remember, to find g over f of 0, you can do that by finding g of 0 and f of 0. It makes the math a little bit easier. So when I plug in 0 to g, I get negative 3. 0 into f, I get positive 1. And negative 3 over 1 is negative 3. Same thing with f times g. It's the same thing as f of 1 times g of 1. It keeps you from having to do all the multiplication and then sub in 1. So 1 squared plus 2 plus 1 be 2, 3, 4 times 4 times 1 is 4, minus 3 is 1, and 4 times 1 is 4. Much quicker than doing the actual operation and then plugging in, and it's a multiple choice test, so that is definitely an option for you.